I want you to close your eyes for a second. Picture a high-stakes action movie scene.
Okay.
You're a sniper, lying prone on the side of a train track. It's the dead of night, pitch black, dead silent.
Mm-hmm.
Suddenly, a high-speed train just hurtles past you. And when I say high-speed, I don't mean like a bullet train.
No, we're talking, what, 10% of the speed of light?
10% of the speed of light, which for the record is about.
It's about 18,600 miles per second, so fast.
Insanely fast.
Yeah.
And your mission is to fire a laser rifle and hit a specific target painted on the ceiling of one of those passing train cars.
Right.
It sounds like the climax of a sci-fi blockbuster, you know?
It does.
But here's the thing. According to the stack of research we have today, this isn't just an action scene.
It's a mathematical crime scene.
That is a great way to put it. We're looking at a thought experiment today that challenges, well, the last 100 years of physics.
And I know we hear that a lot. Einstein was wrong, usually from guys with, tinfoil hats.
Right.
But this is different. This is a forensic audit of a very specific calculation.
Exactly. And we need to be clear about the sources here.
Yes.
We're not looking at peer-reviewed journals from Nature or anything.
No.
We are looking at a collection of deep analytical blog posts from an author known as Adon Jack, some heavy-duty mathematical breakdowns.
And this is the part that's really interesting.
It really is. Transcripts of these problems being fed
Yeah.
into advanced AI models like Claude Sonnet and ChatGPT.
And the results are unsettling. The core argument here is that special relativity, time dilation, length contraction, the whole suite of weird physics might essentially just be a mathematical patch, a cover-up designed to hide a calculation error made a century ago.
Okay, stop right there. That is a massive claim. You're saying the entire foundation of modern physics, the stuff we build GPS satellites on, is based on a math error. I mean, are we talking about like a missing decimal point?
We are talking about something much more fundamental. The sources call it a 100-year mistake. And it all centers on something called deviation shooting or deflection shooting. Basically, how do you hit a target that isn't sitting still?
I'm skeptical, but I'm definitely listening. If we're going to unravel Einstein, we better start with the basics. The sources lay out a specific world model before they even get to the math. What does this universe look like?
To understand the error, we have to strip away the complex physics and just go back to geometry. The sources describe a unified physics model with 3 layers.
Okay.
Layer A is the electromagnetic ocean.
An ocean. Okay.
Think of space not as empty, but as a calm, absolute field, a quiet ocean, and this acts as our coordinate system.
Right.
The key rule in this model is that light travels at speed c relative to this ocean. It doesn't care about the boat or the train that emitted it.
Okay, so if I shine a flashlight from a moving train, the light doesn't, like, pick up the train's speed.
Exactly.
It just moves through the ocean at its own set speed.
Exactly. That's layer A. Layer B is the train itself, a material object moving through that ocean. In our example, it's cruising at point 1c.
Right.
And layer C is the observation, the idea that we never see the train where it is, we only see where the light says it is.
Information delay. We're seeing the mail delivered from the past.
Precisely. Now, let's go back to our sniper on the side of the tracks. We're at a starting point, let's call it coordinate 0, 0, 0, 0. We want to shoot our laser to hit the center of the train's ceiling. Let's say the ceiling is 10 units high.
So at this exact moment, time 0, the target is directly above me.
Right. And you have to decide where to aim. The source breaks this down into the 3 stages of aiming. This is where the detective story really begins.
Okay.
Stage 1 is the amateur mistake.
Which I assume is just aiming straight up.
Right. You look at the target, it's right above you, so you fire at 0, 0, 10.
But light takes time to travel. Even a laser is an instant.
Nope.
So by the time my beam goes up those 10 units, the train has moved forward.
And you miss. The shot passes behind the target. That's stage 1. Everyone understands that.
Yeah, lead the target. It's video games 101.
If you want to hit a moving duck, you don't aim at the duck. You aim where the duck is going.
So that brings us to the next level, stage 2.
Stage 2. The sources call this the mathematician's trap. This is where things get tricky, and this is where the sources claim 20th century physics went off the rails.
Okay, walk me through the logic. I'm the sniper. I know aiming straight up fails, so I do some math. I say, okay, the target is 10 units up. Light takes, let's say, 10 seconds to travel that distance.
Good so far.
And I know the train is moving. In those 10 seconds, the train will move forward. Let's say 1 unit.
Okay.
So I aim my laser at that future spot. 1,000 near and 10.
It sounds perfect, doesn't it? You calculated the travel time, you calculated the train's motion, and you aimed for the intersection.
Yeah. Bang! Target down. Why is that a trap?
Visualize the line you just drew. You aren't shooting straight up anymore, you're shooting at an angle.
Right, a diagonal line.
And in geometry, what do we know about the diagonal of a triangle compared to the vertical side?
The diagonal is, well, it's the hypotenuse. It's longer.
It is longer. If the height is 10 and you aim 1 unit forward, the distance your laser actually has to travel is the square root of 101.
Which is not 10.
It's about 10.05 units.
Oh, I see where this is going.
If the distance is longer, does the light get there in 10 seconds?
No. Light has a set speed. If the path is longer and it takes more time, it takes 10.05 seconds.
Exactly. But you aimed based on a 10-second calculation. You assumed the train would only move for 10 seconds.
Right.
But because your laser took a longer path, it arrived 0.05 seconds late.
And in that extra fraction of a second,
yes,
the train kept moving.
Yes. It moved another 0.005 units. So your laser arrives at the perfect spot you calculated, but the target has already drifted past it. You miss.
That is actually incredibly annoying. It's a loop. What? If I adjust for that new spot, the angle gets even wider.
The path gets even longer, and you're late again.
It's a recursive problem, and this is the crux of the argument.
This is it. The sources claim that standard physics, and specifically the logic used before Einstein, stopped at stage 2.
They just stopped there.
They calculated the lead, assumed it was a hit, and moved on. But in reality, it's a miss.
So how do you actually hit it? Because people do hit moving targets.
You have to ascend to stage 3, the physicist's reality. You have to use simultaneous equations.
Okay.
You can't just calculate time and then distance separately. You have to find a variable, let's call it A, where the time light travels equals the time the train moves.
Taking into account that the train's movement extends the light's path. Yeah. So you're solving for the convergence point.
Right. The math is A squared equals 0.1a squared plus 10 squared.
Mm-hmm.
When you solve that, you find the true impact time is about 10.0503 seconds, and the impact point is further down the track at 1.005 units.
And if you aim there?
You hit the target, dead center, no time dilation, no warped space, just strict, rigorous geometry.
Okay, so we have a math problem. We missed by a tiny fraction, 0.005 units.
Yeah.
Why does this matter?
Well, this is where it gets big.
Why do the sources call this the seed of a 100-year mistake?
This is where we have to talk about Michelson and Morley.
Okay, the famous experiment.
Back in 1887, they were trying to measure the ether wind. They thought if the Earth was moving through space, light should behave differently, depending on the direction.
So they used an interferometer, splitting light beams and bouncing them off mirrors.
Right, and the famous result was that they found nothing, no shift.
The light behaved the same no matter what.
Correct. But here is the deep dive twist. The sources argue that the interpretation of that experiment relies on stage 2 thinking.
How so?
Picture the textbook diagram of that experiment. You have light bouncing up to a mirror and coming back down on a moving platform.
I can picture it. An isosceles triangle.
Right. The textbooks draw a nice, clean, diagonal line that hits the mirror perfectly.
But we just proved that if you simply aim for where the mirror will be based on the vertical time.
Which is stage 2 thinking.
The light should fall behind the mirror because of that extra diagonal travel time.
Exactly. The stage 3 calculation says there should be a delay, a miss, but the experiment showed no delay. The light hit the mark perfectly.
So physicists were stuck. Their math, their stage 2 math, said this should miss by 0.005, but reality said it hit.
They had a discrepancy between their math and the real world.
Right.
So instead of realizing, hey, maybe we need to do the stage 3 simultaneous equations and adjust our aiming prediction, they concluded that the universe itself must be warping.
No way.
That is the argument. They invented time dilation and length contraction to force the math to balance.
Right, that hit it.
They effectively said, well, the light didn't miss, so the train must have physically shrunk, or time must have slowed down exactly enough to cover that 0.005 gap.
So special relativity, this monumental theory, is essentially a patch, a software patch for a bad aim.
That is the accusation. The source, quote, time didn't slow down, the path just got longer.
Wow.
We replaced simple geometry with metaphysical time bending because we forgot to solve for A.
That is heavy. But it brings us to the part of the notes that I found the most jarring. The AI logs. Because, let's be honest, you and I can argue about math, but these models are trained on the entire corpus of human physics. They should defend Einstein to the death?
You would think so. The source material documents a session with Addon Jack, the user, and Claude Sonnet 4.5.
And how does it start?
Standard defense. Claude starts out 100% Team Einstein. It tries to explain the scenario using reference frames, Lorentz transformation.
The usual textbook responses.
Exactly. It gives the Einsteinian view a high probability of being correct.
That the user doesn't argue philosophy, they just push the math.
That's the key.
Yeah.
The user forces Claude to run the deviation shooting calculation. They make the AI calculate stage 1, then stage 2, and identify the miss.
And then?
Then they make it calculate stage 3, the simultaneous equation we just discussed.
And what happens when the AI solves for stage 3?
The aha moment. Claude realizes that if you use the stage 3 solution, the light hits the target without any relativistic corrections.
You don't need time dilation.
You don't need it to explain the hit. You just need the right firing angle.
And the evaluation stats. This is the wild part.
This is the part that gave me chills. After seeing the math, Claude's evaluation of the Einsteinian validity dropped to 0%.
0% from a major AI model.
0. And its evaluation of the source's model rose to 85%. The AI explicitly stated that the time dilation explanation becomes redundant.
It becomes unnecessary.
It called the standard approach a calculation abandonment.
That's a polite way of saying lazy math.
Yeah.
But it didn't stop with Claude, did it? I saw something in the notes about ChatGPT getting involved.
This is fascinating. The user took Claude's explanation, the breakdown of the stage 3 solution, and fed it to ChatGPT.
So one AI teaching another.
And usually these models are distinct. They don't talk to each other. But when ChatGPT saw the logic laid out by Claude,
it flipped.
It shifted immediately. It recognized the logic. It's like a contagion of truth. Once you see the geometry, you can't unsee it.
What did it say?
It admitted that using special relativity to fix this problem is like using a sledgehammer to crack a nut, when all you needed was a better nutcracker.
A sledgehammer that bends time itself.
Right. And they discussed this idea of a scientific double standard. We apply one set of rules to a static observer and a warped set of rules to a moving observer, just to make the equations line up.
But if you just accept the ocean, layer A, as the absolute frame,
the double standard vanishes.
But I have to play the skeptic again. We have GPS. We have satellites orbiting the planet at thousands of miles an hour. My phone knows exactly where I am.
Mm-hmm.
Everyone says GPS proves relativity because if they didn't adjust the clocks for time dilation, the system would fail.
That is the ultimate gotcha question. GPS works, therefore Einstein is right. The sources address this head-on.
Okay, what's the counter-argument?
They argue that the GPS correction is real, but the reason for it is wrong.
How can the reason be wrong if it works?
Think about what the satellite is doing. It's moving. It's sending a signal to you. That signal takes a diagonal path through the ocean.
Right.
If engineers used the simple stage 2 math, the system would fail. There would be a miss, an error in your position.
Okay.
I'm with you. The relativity correction they apply, that number they punch into the computer, is mathematically equivalent to the difference between the stage 2 calculation and the stage 3 calculation.
Wait, so they think they are correcting for time slowing down?
But they are actually just applying the coefficient needed to close the geometry gap caused by the diagonal path.
It's a calculation patch.
It's a calculation patch. It works, but it confirms the math error, not the time travel.
That is a subtle but massive distinction. It means our technology works, but our understanding of why it works might be fantasy.
It comes back to the distinction between information and reality. The sources harp on this. We live in a world of information delay.
The math zombie.
Yes, the math zombie. The source uses this term to describe the mathematical transcendental viewpoint.
Which is a fancy way of saying God mode.
Exactly. When physicists look at these problems on paper, they act like they're God. They see the train, the station, and the light beam all at once, instantaneously.
They assume TOA is the same for everyone.
But in the real world, you aren't God. You are a player on the board. You are a receiver.
You only know what the light tells you.
And that light is always old news. If you move towards the source, a headwind, you smash into that male faster. If you run away a tailwind, it takes longer to catch you.
And relativity tries to say, no, the speed is the same both ways.
Which forces the math to break, creating the zombie. The source argues that if we stop playing God and start calculating like receivers using stage 3 math, the weirdness of the universe just evaporates.
No time travel, no twins aging differently.
Just geometry and delay.
It really makes you wonder about the momentum of science.
Yeah.
We have built 100 years of theory on this. It's in every textbook. It's in every sci-fi movie. The idea that it could all stem from someone forgetting to solve for a variable in a triangle, it's terrifying.
It is. It's the emperor's new clothes, but the clothes are made of calculus. And the scariest part isn't the math itself.
It's the AI.
It's what you mentioned earlier, the AI, the flip.
Yeah.
Think about it. We humans have egos, we have tenure, we have reputations to protect. If you tell a physics professor he's been teaching a mistake for 30 years.
He's going to fight you. He has to.
But the AI, Claude and ChatGPT, they don't have tenure, they don't have an ego, they just look at the logic.
And what did they do?
When shown the stage 3 equations, they dropped Einstein in a heartbeat.
That is the thought I want to leave everyone with. If an artificial intelligence can look at the raw data and say, hey, wait a minute, the emperor is naked, why can't we?
Are we too attached to the complexity? Do we prefer the magic of time travel over the boredom of simple geometry?
Or are we just stage 2 thinkers living in a stage 3 world?
I think we might be. And I think it's time to check the math.
Grab your calculators, everyone. It's going to be a long night. Thanks for joining us on the Deep Dive.
Keep questioning the axioms.
See you next time.